So then you can rewrite your equation. So now you have the equation for P of t, 2/3 2t minus 1 cubed plus 3t plus 1/3. And then if you need to find the position at 2, you would just plug 2 in. Okay, so remember, we haven't done a ton of these this way, but another way is just doing antiderivative, do the plus c, solve for it, and then plug it in. So now we're just going to position. Yeah. Oh no, I just put that up there for a fun fact.
Yeah, but like, would we need to write that on an FR2 question? Because like that's sometimes the point is like writing the integral to then solve.
No, it'll ask you if it wants the integral. Because like on the quiz or test, I think it was a test, it asked for it. So then, yeah, you would write it. But otherwise, usually I've seen these as multiple choice. So I usually do it this way because I think it's a little faster, personally. But I got 73/3. I just did that in my head. Definitely didn't look at my notes. Okay. Okay. Maybe as a side note, a lot of you guys got this right. Side note. If you wanted the total distance, you don't care where you started. You could have started at like 50 or -400. Like think of a track. Like who cares where you start? You just want to know how much you were running or the particles moving, right? So like if you needed to do just straight distance, you would just have to integrate from like between 1 and 2, for example, if you're doing that same bound. That's the absolute value. A lot of you got that on that test, but that you'd throw in your calculator. So just remember for like distance, that one you don't need your initial condition. So again, review, but just to like make sure how you do that. Whew. All right, so then this next one is like you're interpreting like all the different integrals and whatnot that you're doing. So it says you've got lemons on a tree, so not random at all, is modeled by the known function L of t, where t is in weeks, L of t is unknown, L prime is lemons per week, is known, as is the fact that L of 5 equals 5. Use the above information, interpret with correct units the following expressions in the context of the situation. So when I do these, it's really easy to be like, because like this one, when it's physics stuff, it's easier because if you're going from velocity, position, or whatever, you know, acceleration, that's easier. But now we're like talking about freaking lemons, like what, you know? So what I do with this is I use the fundamental theorem, as in I'll rewrite it. So like, because then it helps me like figure out what's going on a little better or conceptualize it. So I'm just going to rewrite it. I know this seems stupid, but I rewrite it as like, okay, if I did the antiderivative of L prime, it would just be regular L, right? And I would do, it would be like this, right? From 1 to 4 or whatever. You do the antiderivative. I don't know the equation, so I'm just doing the notation or whatever, which is, then I would plug in the 4, and then you would plug in the 1, right? So what that means is if you're looking at what L is, okay, that's the number of lemons. And then 4 and 1, these are like weeks, right? So 1 and 4, these are like your weeks. And then this like L is the number of lemons, right, at those times. So this is equal to whatever 13. So if you're dealing with L, you know that it's going to be just straight up lemons. It's not going to be a rate. But then you have to like conceptually talk about it. So basically what's happening is between 1 and 4 weeks, you got more lemons, right? Because you're finding this means like subtraction means like change. So like the change between lemons from 1 to 4 is 13. So if you were to say this to like a non-math person explaining what this means, you would say between 1 and 4 weeks, like the number of lemons increased to 13, right? Like on the tree. Or like the change in lemons between 1 and 4 weeks. So there's 13 more lemons, you know? Because like when you're doing subtraction, it's like you're finding the change between the 2 weeks, right? So, because L of 1 would be how many at 1 week, L of 4 is how many at 4 weeks, and then you're subtracting them. So it's like how much went up, right? Same with this one. I'll like rewrite it so it's like looks more like this thing, you know? And then I can kind of figure out what's going on. Some of you might already look at that and know what it is. But what might help is like, okay, if you rewrite that, that'd be L of 5 plus, and then if you rewrite this just like I did on the other one, you know, with the subtraction, that'd be L of 7 minus L of 5, right? Basically, I would subtract in, but if you notice, the L of 5s cancel. So like, what ends up really, if you were to simplify this, you get the 24 equals, and then you're just left with L of 7. So it's this equation, so like the reason you're always putting that initial condition in is because when you're doing your integral, these two cancel out, and it's just basically how many lemons at 7 weeks, you know? So that's why it works. So this is, there are 24 lemons at 7 weeks, right? Yeah, okay. Then this, again, all this stuff is like practice with it. So here we have f of x to the right. It's known that g prime equals f. So usually what I do is I'll like label it ridiculous on here on the graph, so I like don't forget what's going on. And then we're given an initial condition of where to start. So if I'm going to evaluate this, right, again, go back to like this idea with your fundamental theorem. Just rewrite it where you're doing, okay, this would really be f of 8 minus f of 1. And then for this one to figure it out, okay, this you're getting f of 8. So you're looking, this is the graph of f, so this is just straight up points, right? So like for this one, you're just using like points on the graph because you have regular f, and that's the graph you're given. So there's no area under it. Like if it was regular f integral, then I would be doing areas. But just because we're taking f prime, we're not given f prime, that's why I'm using that fundamental theorem. So f of 8 is 5, and f of 1 is 0, so the answer is 5, right? Whereas like in a different question like this guy, this one, you're going to have to do area because you're given actual f, right? So this is like an area problem because you're doing area under the curve integral. So just being careful with notation, basically. So 0 to 6. So 2, and then we've got 6, and then we have to subtract the 3 because you're doing, it's underneath the x-axis. So that's also 5, which is weird. Now if I want just straight up g of 8, so again, I just want a plain number, just like here. This would give me L of 7. Do you want it by canceling out? So if I want g of 8, that means I have to use that initial condition for this one. So g of 8 would be your initial condition 7 plus integral, and you have to start at 4. And since you want to go to 8, and you're going to integrate g prime. And again, if you don't believe me, it's because if you were to do this using the fundamental theorem, you'd have g of 8 minus g of 4, and that would cancel out the 7s. You know what I mean? So you'd be left with g of 8. That's how you know it works out. So you get 7 plus, and then this would be g prime is from the graph. So this is going to be an area thing because you're given g prime. So from 4 to 8. So that'd be what? Negative 3 plus 7, pretty much. I don't know, just review, I guess, with the notation. Is there any questions with stuff, any of that? Okay. So I might want you guys to try this one. So the rate at which garbage lands in a bag is modeled by g of t. The rate at which garbage leaves in an inconveniently located hole is modeled by L of t. Why didn't I use h? But whatever. Okay. They're modeled in pounds per hour. At time 0, there's 20 pounds of trash in the bag. Use the information to set up expressions or equations. So why don't you guys try it? See what happens. See if you can come up with the equations. You don't actually have to solve them. Ready to go. Guys, ready? Okay. So, enters, that's just straight G of t, 0 to 5. I don't care how much started. It's just saying, like, how much is going in there. Okay? Exits, 0 to 5 is just L of t, because these are rates, right? Now, in the bag, now I care that there's 20 already in there. 20 pounds, that's a lot. Okay? So, 20 is already in there. I have to add in what's going in and subtract what's going out. You could put the G of t and L of t together because they're in the same bounds. So you could. So I put both of them there. And then when is the amount of garbage in the bag constant? So I was like, well, what does that constant mean? That means that it's not changing. Like it's staying how it is, you know? So then to think about that, these, remember G and L are both rates. So you could either think about it, okay, when the going in and going out are the same, because then it just stays like whatever the pound is. Or you could think of it, if I were to subtract them, it would be 0. Because think of like derivative of a constant is 0. So that's why it's that one. Is there any questions? Okay. And then these guys, yeah, just the reading, honestly. So, function f of t gives the rate of evaporation of water in liters per hour from a pond where t is measured in hours since 12 noon. Which of the following gives the meaning of that? The context described. So usually I'm annotating this like f of t is liters per hour, and f of t is in the integral. Okay. So if you're integrating liters per hour, I usually, if I'm integrating it, that's just going to be straight up liters, right? Because you're going, think of like velocity to position, right? So what I do is I just kind of like knock out the ones that don't have that unit. So this one's liters per hour, so that one's out. This one's liters per hour, out. Liters per hour, out. You know what I mean? And now you have a 50-50 shot of getting it. Okay, so total volume in water in liters, so this is legit, this is good. Evaporated from the pond in the first 10 hours after 12 noon, or between 4 and 5. I mean, you have, or 4 and 10, you have 4 and 10 on the integral, so, whoops, wrong one. This guy, so B would be the answer, right? So, that's what I do. I just look at units. I don't really read through them all. I just look at the units and then just like cross out ones as I go. Okay. This one, snow is falling at a rate of blah, blah, blah inches per hour, and t is measured in hours since the beginning of the snowfall. Which of the following expressions gives the amount of snow in inches from the time t equals 0 to time t equals 5? Okay. So, essentially, right, if we have inches per hour on this thing, and I want straight up amount in inches, okay, we're going to be looking at an antiderivative, right? So that's essentially what we're doing is we're going to integrate because I want inches. So I'm going to have to integrate from 0 to 5 of this 2e to the negative 0.1t dt. And then, I keep yawning. You could do a u sub on it, or you could kind of, think of that, that's negative 1/10. So, it kind of depends on if you can do some of this in your head because the exponent's not too crazy. So, if you know the antiderivative is going to be e to the negative 1/10 t, but because the exponent's all wild looking, you know that's going to be negative 20 because you're going to multiply by negative 10. So, you're like multiplying by the reciprocal number, and this is going from 0 to 5. And don't waste any of your life if, think about if you're going to plug 5 in, or just look at all your e's. Like this is the only one with 20 in it. You know what I mean? So you can kind of cheat, which is what I would recommend. Does that sound horrible? Maybe. Oh well. Okay. Nope. Got 2 more. Well, we got this. The nut strategy. Yes. The nut strategy. Yeah, we'll do a couple. And then you guys can try it. Okay, so the explanation. Okay, I had to add this in because this was like the most wrong on the test, was this explanation. This and this integral. Those were the most wrong on the whole test. Okay, so you guys need that nut strategy, you know. So stupid. This is the acronym. But it's basically noun units time. So tank initially has 50 gallons of honey. Okay, cool. This isn't random at all. Honey is added to the tank at a rate of this per hour and removed from the tank at that per hour. Okay, student's response represents the amount of honey in the tank in gallons over the time interval 0 to 2, and there's something wrong with this. And the big idea here is they have this 50, right? This is initial condition. Now remember, when you're integrating that, remember you get rid of that initial condition at 0. When you're doing that integration, remember it cancels out, like that lemons thing? Where's the lemons?
Lemons.
Where's the lemons? This guy. Remember? The 5 and the minus L of 5, they canceled. So when you're doing that initial condition, we don't need a range of time. The part that's messed up, again, is the time. We need it straight up at 3 because we're including that initial condition, okay? Maybe I'll do one more mosquitoes, and then you guys will do these other ones. Sorry, Ben. So this one, number of mosquitoes on a tropical island, where M is the number of mosquitoes in thousands and T is the number of days since the beginning of the year. Okay? So you have 1 over 30, represents the average number of mosquitoes on the island. Okay? So average number, that's your noun, right? This is going to be your unit. And then you have your, between the beginning of the year and the 30th time of the year, this is your time, right? So noun, unit, time. So there's something wrong with it, okay? So what I do is, usually I check units, to be honest, first. But I would do like 1 over 30. I almost always check units first. So I go 1 over 30, that would be days, because 30 is a time frame, right? So that's going to be 1 over days. And then the integration of M prime would give me just regular M, right? So what that is, if M is the number of mosquitoes in thousands, this is the number of skeets. That's what we call them in our house. Get those skeets out of here. No one? No one else? Okay. Little glimpse into my life. So, God, these dang skeets. Do you know Mr. Jordan? They like attack him, and I'm fine. Every single time.
My mother and me get attacked.
I think it's a blood type. I don't know. Okay. Random fact. Okay. All right. So we're in thousands per day. So we got skeets per day. So we're good. So units is fine. So that's good. Now they're saying average number of mosquitoes on an island. Well, we're doing skeets per day, right? So why would I say that's average number? Do you know what I'm saying? They're saying of number of mosquitoes. So this isn't like average. It's definitely average because it's like that 1 over 30 piece of it. But my unit is skeets per day. So I'm not going to say average number of mosquitoes. I'm going to say the average rate of change in the number of mosquitoes, right? So this is going to be, the noun is what's messed up. This is the average rate of change in the number of mosquitoes. If it was just regular M, is that what you're saying?
If the noun part was right, would it just be mosquito?
Yeah. Or in thousands, yeah. But then that would also be regular M. Then it would be good. So if it was regular M, you would say average number of mosquitoes in thousands.
With the integral?
Mm-hmm. Yep. Yep. All right, so why don't you guys try these? Just these last three. See which one's wrong. Okay. Yep. Like, this is going to be wild. I should freeze it.